So what is deep learning? Deep learning is a machine learning technique that teaches computers to do what comes naturally to humans. It's a subset of machine learning, which is essentially a neural network with three or more layers. It will attempt to simulate the behavior of human brain. The neural network with a single layer, whereas deep learning with multiple layers. It drives many artificial intelligence applications and services that improve automation and performing analytical and physical tasks without human intervention. It's behind everyday products, whatever the products we are using nowadays. It's a pipeline of modules, all of which are trainable. It has multiple stages in the process of recognizing an object, and all of those stages are part of training. In case of traditional pattern recognition, so we use fixed feature extractors. In case of mainstream modern pattern recognition, so we have mid-level features. In case of deep learning, so we have low-level, mid-level and high-level features. All the representation are hierarchical and trained. So if we observe the various things, so machines can one day be as intelligent as human. They predicted in 19th century. So they build an intelligent machine, AI. The intelligent machine, AI, and next is machine learning, and in deeper is your deep learning. The basic process in deep learning, so what a data scientist or analyst will do is, you need to understand the problem and whether deep learning is good for it or not. You need to identify the data sets and prepare them for analysis, and select the type of deep learning algorithm. So we have various types of deep learning algorithms which we will be discussing in later. And train the concerned algorithm, whatever the selected algorithm, on large amount of labeled data. And then finally test the model's performance against unlabeled data. So these are the stages in deep learning applications what a data scientist or analyst will do. And this diagram clearly depicts how deep learning is a subset of machine learning, a subset of AI. So AI, and we have machine learning, a technique by which a computer can learn from data. And deep learning, a technique to perform machine learning inspired by our own brain's network. AI versus machine learning versus deep learning. AI in 1950s, whereas ML in 1960s and deep learning in 1970s. AI is a subset of data science, whereas machine learning is a subset of AI and data science, and deep learning is a subset of machine learning, AI and data science. And deep learning is a process of using artificial neural networks to solve complex problems. Aim to build machines which are capable of thinking like humans, AI, and aim is to make machines learn through data so that they can solve problems. Machine learning. To build neural networks that automatically discover patterns for feature detections is deep learning. So we have 10 applications of deep learning. Is self-driven cause, automatic handwriting generation, detection of growth delay in children, and pixel restoration, automatic machine translation, and etc. We'll be discussing one by one with an example in detail later. The most important thing is if deep learning is a subset of machine learning, then how do they differ? All the machine learning algorithms are structured and they have labeled data to make predictions. Whereas deep learning eliminates some of the data pre-processing that is typically involved with machine learning. These algorithms process unstructured data like text and images and automates feature extraction, removing some of the dependency on human experts. So if we have a set of photos of different pets and we want to categorize by cat and dog, and deep learning algorithms can determine which features are most important to distinguish each animal from another. Whereas in machine learning, this hierarchy of features is established manually by a human expert. So that's the main difference. Through the processes of gradient descent and back propagation, the deep learning algorithm adjusts and fits itself for accuracy and allowing it to make predictions. So we have supervised learning, unsupervised learning, and reinforcement learning, various models. The supervised learning utilizes labeled datasets and requires some kind of human intervention. Unsupervised learning doesn't require labeled datasets. It detects a pattern, and whereas the reinforcement learning in which a model learns to become more accurate for performing an action in an environment based on feedback in order to maximize the reward. So we have another diagram: AI, ML, and artificial neural network and deep learning. So we'll see an example of how deep learning works. So let's say that we have a goal to recognize photos that contain a dog, an animal, and all dogs don't look exactly alike, and the photos with dogs in different angles and with varying amounts of light and shadow and etc. So all the images, the training set of images must be compiled, including many examples of dog faces and the pictures of objects that are not dogs and label them as not dog. And you need to put all the images into a neural network which are converted to data. These data move through the network with various nodes and assign weights to different elements. So what is important is once answer received from the neural network, it's compared to the human generated label. If there is a match, then the output is confirmed. If not, it notes an error and adjusts the weightings. It will try to improve its dog recognition skills by repeatedly adjusting its weights over and over. That is very important here. And this training technique is called supervised learning. They must recognize the patterns in data over time and learn on their own.